So you're preparing a solution and you make it. Go ahead, you prepared a 2.5 molar solution. You bring it up to your boss, and your boss says, I asked for a 0.25 molar solution. Rather than throw it out, you can say to him, oh, I know how to dilute that down. I'll just modify that for you. This is known as diluting and concentrating. It happens all the time in the natural world, right? When salt water mixes with fresh water at a river, as a river pours into the sea. Whenever you drink a liquid, you are concentrating or diluting something in your body. So these kind of things happen all the time. And there's a wonderful formula that's particularly useful for it. It's simply C1V1 equals C2V2. This reflects the fact that as you add solvent, the concentration decreases, right? So this is an inverse law, so we express it all in a line. Were it to be a proportional law, it would have been C1 over V1 equals C2V2, whereas you might guess C's and V's are concentrations. This is a generic form of it. Now, for AP chemistry, you might be better off just writing capital M1, V1 equals capital M2, V2. Molarity of one times its volume equals a molarity of another times its volume. So you have before and after cases, and usually you know 3 of the 4. Let's do a problem. I need to dilute 53.4 mils of a 1.5 molar aqueous brine solution, that's sodium chloride, to make it 0.8. Notice it's dilution. It's going down. So how are we going to do it? Let's just label each thing. Right, C1V1 equals C2V2. This must be your V1. This is your C1. This is your C2. Plug in and solve for the unknown. V2 will equal 1.5 times 53.4 divided 0.8, because if we divide both sides by 0.8, we isolate V2, which is what we want. V2 equals, right? And so it's actually 100 mils. So we need to take, the answer is not 100 mils, is it? Look, the answer is how do you do it? So we need a sentence. Take and dilute. Take your 53.4 mils of 1.5 molar and dilute to 100 mils using water. And that's how you do it. You should be now in a position to dilute or concentrate solutions as you need. If it's a concentration thing, say we're going to 3 molar, you'll solve, you'll get an answer, and you just change really one word, concentrate to. That would imply that you just need to remove solvent. Since water is usually the most volatile thing in the mixture, that's all you need to do. If you had a weird case where it was not, then boiling it down would not do the trick, and that would be a more challenging problem. Probably better off just making it from scratch if you could. But in any event, this is dilution and concentration.